you are new to this channel, please make sure you subscribe, like, and share. Now, today I want to continue on that application of differentiations. Today we are going to talk about the rate of change and the application on rectilinear motions. Now, when I say rate of change, let's start with rate of change. They said the radius of a circle is increasing at the rate of 0.01 centimeter per second. Find the rate at which the area is increasing with the radius of the circle is 5 centimeters. Now, anytime you are to attempt something like this under the application of differentiations, now you will discover that the major thing they are talking about, they talk about the radius, and in the radius we see area of the circle. Inside the area of the circle we see the radius. The first thing that we write the formula out. Area of a circle is pi r squared. You need the formula. That is the first thing you do. Now, if you now look at everything again, you will discover that there are things they talk about. They talk about the seconds, centimeter per second. That means there is time. So everything we are going to be talking about is from area to time. So that means you are dealing with everything we are going to deal with is the A all over dt. The A all over dt. And what will be the formula for the A all over dt? That will be the A all over the R multiplied by the R all over dt. How will I know that there is R? Because they talk about the radius. They talk about the radius, and this radius is talking about the centimeter per second. So it's time. So this is what we are going to. This is the center. This is what we are working towards with. Now, let me get this one first. How will I get it? Since I know my area of a circle is pi r squared, because they talk about the circle here. So let me differentiate the R. What will be my dr? What is the differentiation of pi r squared? That is 2 pi r. So I've gotten that one in the first place. So I need to get the R dt. And actually, what are they talking about? What did they ask us to find? They said the radius of a circle is increasing at the rate of this. At the rate of this, find the rate at which the area is increasing when the radius of the circle is 5 centimeters. That means our radius is 5 centimeters. That means from here I can say 2 pi open bracket 5. That is 10 pi. That is 10 pi. So now that we have known the A, the R, and we are given the R dt to be 0.01, find the rate at which the area is increasing. So we are looking for the area is increasing. We are looking for the area. We are looking for the area. So we have gotten the A, the R to be 10 pi. This one is 10 pi times. What is the R dt here? This is this. 0.01 centimeter per second. Because radius is centimeter all over seconds. So what we now do now? What we just need to do, we multiply them together. That means I'm multiplying the 10 pi times 0.01 centimeter per second. If I multiply 10 by this point will shift one time. That will be 0.1 pi centimeter per second. Or if you introduce that pi, you just say 0.1 times 3.142. So that is the answer for that. Now let's take another one under the rate of change. Now we are having, find the rate at which the volume of a spherical balloon is increasing. If the surface area is increasing at the rate of 5 centimeters square per second, when the radius of the spherical balloon is 4 centimeters. Now let's take a look at this one. They say find the rate at which the volume of a spherical ball. If you take note, they talk about the volume of a spherical ball. And what is the formula for volume? Volume of a spherical ball, it is 4 all over, volume of a spherical ball is 4 all over 3 pi r cube. We talk about the volume here. Now when you continue again, find the rate at which the volume of a spherical ball is increasing if the surface area. They talk about two things here. They talk about the area and they talk about the volume. In the former one we did, they only talk about the area of the circle there. That means, what is the surface area of a spherical? That is 4 pi r squared. Area of a spherical object is 4 pi r squared. The volume is 4 all over 3 pi r cubed. They say if the surface area is increasing at the rate of 5 centimeters squared per second, we should know that this is the A, the T, because that's A all over T. Area is squared. When the radius of the spherical ball is 4 centimeters, that's our radius. Now we are working with these two parameters. Let me shift this one here. V equals to 4 over 3 pi r cubed, while the area is 4 pi r squared. Do not forget, everything you need here is dv dt. That's everything you needed. And dv dt will be what? Like the one I did the other time. Just be dv dr multiplied by dr dt. As if we are doing our function of the functions theory. The same thing, everything we need here is the a dt. And the a dt will be what? The a dr multiplied by dr dt. That's all what we need. That's all what we need. Now, we can get our dv dr from here when we differentiate what we have here. If I differentiate here, to get my dv dr, so if I differentiate this, if I bring this 3 here, that means 3 times 4 over 3, 3 will cancel 3. So I'm going to have 4 pi r squared, because we remove one here. 4 pi r squared for this. Now, if I want to get my a dr here, what will I do? So that will be, if I get the a dr from this, if I differentiate this, if I bring this to here, that will be 8 pi r. 8 pi r. So I've gotten my dv dr, I've gotten my the a dr. But do not forget, we are given radius. But before we sort it, let us calm down. Anytime we are given something like this, what do we do? We are going to divide area by the volume. Area by the volume. Anytime we are given the volume and area together in the same question like this, we are going to divide the area by the volumes. Now, what are we going to do now? Now let me write. Do not forget that this is our rate. I'll clean this side, but we are still going to take those things back. Now, if I divide my area by the volume, that means I'll say the A dt, which is my area, divided by my volume, dv dt. And my dA dt give me, the A dr multiplied by dr dt. Why my dv dt? That will give me dv dr multiplied by dr dt. Now, actually, when we look at it very well, we discover that this one and this one, they give me 1. They are going to give me 1. Let me write this one somewhere because I have to play this side. dv dr, I have 4 pi r squared, and the ADR I have 8 pi r. Now let's clean this side. Now, like I said, the A, the T, all over dV, the T. Now, my dA, the R, what's it? It give me 8 pi R. It's not give me 8 pi R. My dV, the R, give me 4 pi R squared. Multiply by this one, give me 1. What will I do? I can say 4 here 1, 4 here 2. That means I'm going to have 2 pi r, 2 pi r all over. Okay, I can cancel this one, cancel this. R cancel R. So I'm having 2. This one, no, 4a1, 4 that is 2 all over r. 2 all over r times 1. 2 all over r times 1. Well, after that, what will I do? I have the A all over dt divided by dv dt. So I'm having 2 all over r times 1. I can cross multiply because 2 all over r times 1 is still 2 all over r. So if I cross multiply, I'm going to have so that means I'm going to have the A dt equals to, if I cross multiply, I will be 2 all over r times, I bring this one here, times dv dt. I'm going to have something like this times dv dt. I brought this one to this side. So dA dt equals to that. Now, what is the next thing we are about to do? Now, if you check the questions very well, in the questions we are given dA. Now let's check it. The question here, they said, find the rate at which the volume of a spherical ball is increasing. If the surface area is increasing at the rate of, they give us the surface area is given at the rate of 5 centimeters square per second. Now, what is that? That eventually, this is an area, this is not volume. And we are given radius to be 4. Our radius is 4 centimeters. And what they asked us to find, they said, find the rate at which the volume, find the rate at which the volume of a spherical ball is increasing. At which the volume, that means we are looking for this. I'm looking for volume. The rate at which the volume is increasing. Now, the A, the T equals to, the A, the T is actually 5. I don't need to write it again. That means 5, the A, the T, 5 centimeters squared per second equals to 2 all over And what is my radius? My radius is 4 times dv dt. Times dv dt. That means 2 here 1, 2 here 2. That means 5 equals to 1 all over 2 times dv dt. As a simple mathematics, I can just say 5 over 1 equals to 1 times dv and 2 dt. I'll just cross multiply. If I cross multiply, what will I have? That is 5 times 2 dt, that is 10 dt equals to dv. Do not forget, I'm looking for, what am I looking for? I'm looking for dv dt over dt all over dt. So that means 10 equals to dv dt. So that is what we are looking for. And what is the unit for volume? That will be 10 centimeter cube per second. So that is the answer for that. That is all about the rate of change. Now let's go to the rectilinear motion. That means that anytime you are dealing with rate of change, just look at the formulas. Look at what, if they talk about only the area of the circle, deal with that. If they talk about both the area and the volumes, you should know how you manipulate it. Now, rectilinear motion. Rectilinear motions. Now, without wasting our time, rectilinear motion is talking about the motion on a straight line. And the motion on a straight line. And the distance, let's say the distance equals to x. Motion on a straight line. Distance equals to x. And the time is t. Actually, half of x equals to t. And a function, that's y equals to t. Now, but what I want to bring out is that in rectilinear motions, if we are to find the distance that will be dx dt. That is speed. Speed. Dx equals to dt. That is distance. They ask us to find the distance, dx all over dt. Now, but there are rules that are pertaining to this. If an object is moving away, if an object is moving away from rest, the x, the t is greater than 0. If an object is moving towards rest, the x, the t is less than 0. But if an object is at rest, that means the x, the t equals to 0. So these are the three. If an object moving away from rest, it is greater than 0. Coming to rest, it is less than 0. It's at rest, it is equals to 0. That is for the distance. Now, if you are given in case they talk about the velocity also. Velocity is the change of displacement all over time. So that means we can also have, for velocity, you can have the x dt. Dx dt, change of displacement all over time. But if they ask for acceleration, we represent acceleration by small letter a. That means I can just say I can differentiate velocity once more. Because acceleration is the time rate of change of velocity with time. That means if they ask for acceleration, I will differentiate velocity. That means d dt of velocity. That means equals to d all over dt. And what is velocity? Velocity is the x dt. Can I say d square x all over dt square? That means if I'm looking for acceleration, I will need to differentiate that distance 2 times. When I differentiate it 4 times, that is for velocity. I differentiate it again. That is actually for acceleration, because I have to differentiate velocity. If they give me velocity direct, that means I'll just differentiate velocity. So that will be my acceleration. But if they give me distance, I will differentiate it first. I will still differentiate it again. They give me x, I have to differentiate it 2 times. But if they give me velocity, I will differentiate it just once to get my acceleration. Okay? And this velocity also it has a rules as well. If it moves, if it is accelerating, that means your dv dt is greater than 0 if it is accelerating. But if it is decelerating, that means dv dt is less than 0. But if it's moving with constant speed, that means dv dt is equals to 0 at constant speed. Now let's take a look at like 2 questions under this. If you are given something like this, the motion of a particle along a straight line is specified by the equation x equals to 4t raised to power 4 minus 3t cubed. Find the velocity and acceleration after 3 seconds. Now let's look at this. They said the motion of a particle along a straight line is specified by the equation. We are given these equations. X, that's a distance, 4t raised to power 4 minus 3t raised to power 3. They said we should find the velocity. If I'm looking for velocity will be the x distance all over time, dt. My velocity is the x dt. They now said find the velocity and acceleration after 3 seconds. The motion along a straight line. So that means I'm going to differentiate this to get my velocity. So that means my velocity will be, if I differentiate it, that's 4 times 16 t. I'll remove 1 from here. 3 minus I'll bring it times this. That is 9 t. I'll remove 1 for the velocity. Find the velocity and acceleration after 3 seconds. Do not forget, they say after 3 seconds, both for velocity and acceleration. So that means my time here is 3 seconds. So that means v equals to 16, 3 raised to power 3 minus 9, 3 raised to power 2. That means the velocity will be velocity it is 16. 3 raised to power 3, that is 27. Minus 9. 3 raised to power 2, that is 9. So we are going to multiply this together and multiply this together. This one will give us 81 actually, minus 16 times 27. 7 times 6, 42. 7 times 1, 7 plus 4, 11. 2 times 6, 12, keep 1. 2 times 1, 2 plus 1, that is 3. 2, 3, 4. That is 4, 32. So 432 minus 81, that is 1. 13 minus 8, that is 5. And 3. So that is velocity is 351 meter per second. That's for velocity. Now, for acceleration, I told you that if you want to find the acceleration will be dv dt. We differentiate velocity. But if they don't give us velocity straight, like this one, they give us distance straight. Let's say they just ask us to find the acceleration. I told you, it can just be, acceleration can also be d dt of velocity. And I told you that A equals to, what is d dt of velocity? Velocity is dx dt. That means acceleration is d square x over dt square. Either of the two works. Now, we are given, what is the equations given? We are given x equals to 4t raised to power 4 minus 3t cube, 4t raised to power 4 minus 3t cube. So if I want to find my acceleration, that means it will be second derivative, which is this, because it's just a distance. That means the acceleration equals to d square x all over dt square. And when I firstly differentiate it, I got 16. My first differentiation is 16 t cube minus 3 times 3, 9t squared. So if I differentiate it again, 3 times 16, that is 48. 48 t squared minus 18t. That means because they give me x, so I need to differentiate it 2 times to get the acceleration. At t equals to what? 3 seconds. Yes, I guess they say at time t equals to 3 seconds. So just substitute it. That is 48, 3 raised to power 2 minus 18, 3. So what would that one give us? That means we are going to have 48 times, this is 9 minus 18 times 3, 3 times 8, that's 24, 2, 3 times 1, 3, plus 2, 5, 54, 9 times 8, 72, keep 7, 9 times 4, 36, keep 1, that is 4, that is 432 minus 54, 432 minus 54, 12 and that is 8, under 2, 12 and 7, 3. That's going to give us 378 meter per second square. That's for accelerations. So in a nutshell, if we are given distance, we have to find velocity. How will be ds dt? Velocity is ds dt. But if you have to find acceleration, if you are given x, so that means you differentiate it 2 times. But if you are given velocity, you have to find acceleration, just differentiate it once. Now let's take a look at maybe 1, 2 more before. Now, this is second example for rectilinear motions. They said the motion of a particle starting from O, that means it's at rest, is described by the equations that are given our distance to be x equals to t cubed all over 3 minus 7 all over 2 t squared plus 10t. How far is the particle from O? That is the distance. How far is the particle from O? When the particle is momentarily at rest, I told you when we want to start, when they say it's at rest, that means our dx dt is equals to 0. That means our ds dt equals to 0 when it's at rest. That means we have to differentiate this. The s dt equals to, if I differentiate this, if I bring this 3 here, that will be 3 times minus 1 all over 3 minus, if I bring 2 here, 2 times 7 all over 2 till 2 minus 1 plus 10. So the dimension of 10t is 10. So this will cancel this. X dt, that is t raised to power 2 minus this cancel this 7t because 2 minus 1 plus 1 plus 10. So that's ds dt. Now, but do not forget, I said when it's at rest, that means ds dt equals to 0. That means this t, that is t squared minus 7t plus 10 equals 0. It actually equals 0. That means we are going to factorize it. But do not forget, they said, how far is the particle from O? What does that mean? That means how far means distance. So that means we are looking for this back. And they say how far. That means we have to get the value for t. We're now going to substitute it back in the original equation. Now let's if we factorize this, t squared minus 7t plus 10 equals 0. That will be 10t squared. For the two values we need
minus 5t.
Yes, minus 5t minus 2t. Now the t squared minus 5t minus 2t plus 10 equals 0. Now the t open bracket minus 5 minus what is common here 2. T minus 5 equals 0. So definitely we are going to have t minus 2 and t minus 5 equals 0. So definitely we are having t equals to 2 or t equals to 5. We factorize it, that's what we are going to have. And do not forget, they say how far. We are looking for distance. That means I'm looking for distance. And how are we going to do that? We are going to substitute. So when our t equals to 2, we want to get our distance. That means our distance is 2 raised to power 3 all over 3 minus 7 all over 2, 2 raised to power 2 plus 10, 2. That means x equals to 2 raised to power 3, that is 8 all over 3 minus 2 raised to power 2, that is 4. 4 times 7, that is 28 all over 2 plus 10 times 2, that is 20 all over 1. What I'm going to do, that means x equals to 8 all over 3. If I were you, I will reduce it. I'm going to reduce it. That's 14. 14 all over 1 plus 20 all over 1. I'll find the LCM 3. 3 3 1. 1 times 8, that is 8. Minus 3 1 3. 3 times 14. That is 12. 1 42. 42 plus 3 1, that is 3 times 3, that is 60. So definitely I'm having 8, that's 68 minus 42 over 3. And that is what? 68 and 42, that is 6 and 2. That is 26 all over 3. That is when t equals to 2. Now when t equals to 5, what will I have? When t equals to 5. So I'm going to have when t equals to 5, I'll have x equals to 5 Cube all over 3 minus 7 all over 2, 5 plus 10, 5. And x equals 5 raised to power 3, that is 125. 125 all over 3 minus 25. 25 times 7, 35. 14 plus 3, that is 17. That is 175 all over 2 plus 10 times 5, that is 50 all over 1. So you can find the LCM. That as well. Our LCM will be 6. So 3 is 6, that is 2. And 2 times 125, that's going to be 250. 250 minus 6 divided by 2, that is 3. 3 times 175. 175 times 3. 525. 525 plus 6 in 1, that is 6. And 6 times 50, that is 300. Having 250 plus 300, that's going to give us 550. And 550 minus 525, that is 25. 25 over 6. That means when t equals to 5, the distance is 25 over 6. When t equals to 3, the distance is 26 over 6. Now, lastly, under the rectilinear motion, do not forget when it's at rest, momentarily at rest, our ds dt equals to 0. So that means you have to find the ds dt, and they ask you to find the alpha, that's the distance, and the distance is x. Do not forget distance is x, but velocity is ds dt, while acceleration is t s squared all over dt squared. That means acceleration is differentiated twice if you are given x, but if you are given velocity, just differentiate velocity once. So to get your acceleration. Lastly, body is projected find the time taken to reach the greatest height. The greatest height reached. So lastly, we're going to talk about this. It said a body is projected vertically upward, and the height, in meter, reached after a time t is given by this. This is the height. Find the time taken to reach the greatest height. Now, when you hear the word time taken to reach the greatest height, in the application of differentiations, greatest height, that is maximum. That is maximum. And I told you in the previous video when I was explaining the maximum and minimum, I told you both maximum and minimum, they are under turning points. And if it is under turning point, the ydx is always equals to 0 at turning point. The ydx is always equals to 0. Please, if you have not watched that videos, try to do so. Now, if the ydx is always equals to, they ask me to find the time taken to reach the greatest height. That means for me to get the time taken to reach the greatest height, I have to differentiate it and make it equals to 0. That means the h, the t will equals to 0 because I have to differentiate h against t. And what will not be my h, the t? If I differentiate this, 196t, that is 196. The dimension of 196t is 196 minus 4 times 4.9. 4.9 times 2. That is 9.8. 9.8. Now I will remove one here. And I remove one here. T. So when you remove one here, you don't need to write it. So that is, but don't forget, they say time taken to reach the greatest height. That means your the h, the t equals to 0. That means 196 minus 9.8t equals 0 at the turning point. Our ydx equals to 0, whether maximum or minimum. So let me collect lifetimes. Let me just bring this one to the other side. That means 196 equals to 9.8t. All over 9.8, all over 9.8. This cancel this. That means my t is the time taken 196 divided by 9.8, that is 20. The time taken to reach the greatest height is 20 seconds. It's 20 seconds. Now, B said the greatest height reached. The greatest height reached. Already, we are given height. The height is 196t minus 196t minus 4.9 t squared. 4.9 t squared. That's our normal height given to us in the original equations. So for us to get the greatest height reached, that means we are going to refer back to our normal equation given to us, which is this. And for me now to get this value for this height, that means I have to substitute for my t, which is 20, to get the greatest height reached. That means the height equals 196 20 minus 4.9 20 raised to power 2. That means 196 times 20, 3,920 minus 20 raised to power 20, that is 2, that is 400. And 4.9, that is 400. 1,960. That is my greatest height reach with 3,920 minus 1,960. That is 1,960. Okay. That is my greatest height reached. So please watch and watch again. And if you have not subscribed, that is the only way you can help this channel. Make sure you subscribe and you share to other people and then learn. Thank you so much.